couple things I wanted to show this week to start out with. Some super basic settings that you're going to always want to have on when you're doing 3D toolpaths. I mean, it's pretty fundamental, but I want to take a look at some of the things and some of the reasons why. So I have this part here that has, kind of this area on here that I want to machine in 3D. I've roughed this out and thrown a facing toolpath on it. That's pretty simple. When we look at this contour toolpath, most people would probably look at this and say that looks pretty good, right? Right, Phil? It's kind of looks like it's doing the spot we want. And I guess don't allude to the problem, but I'm going to show it. But most people would probably say this looks pretty good, right? This looks to me like an offset of the surface, right? So the distance that we have here is pretty level. If we look at this from the side, pretty level with the top and with the bottom of the toolpath. Obviously, it's stopping a little bit there, but this for the most part looks pretty close. Now, when we go to simulate this, what we'll see is it's not going to finish all the surface. So one of the things that we do when we're drawing toolpaths like this, or drawing the blue section of the toolpath, not here in the stock simulation, but when we were looking at that toolpath earlier, is we're showing the tip of the tool. We're not actually showing the contact point. So if I drag this around here and we go to the side, and I'll maybe turn the stock off for a second. As we come over here and we get to this corner and this edge, which is a little bit hard to see, but we have essentially the tip. I don't know why that does that, but we have the point here at the tip, and then we have the point where it's touching the part, right? And this is kind of on a little bit of a link move there, right? But we have this point where it's touching the part and contacting the part, and then we have the portion where the toolpath is drawn over here. So you can see there's a little bit of distance between the two of those. So the most basic setting that you pretty much always want to have on here is going to be contact point boundary. Now, if we take a look at this one, and I'll shift it up here a little bit, and I'll show you where you can find the setting. In geometry here, it's going to be right here, contact point boundary. This setting you're going to want to have turned on, and what this is going to allow us to do, if we hover over this, hopefully it'll show me, maybe on this try. On the upper left here in this diagram, it shows disabled, and that kind of red dotted line straight up and down is the boundary selected, but we're looking at it obviously from the tool axis orientation, and it's not going to allow the tip of the tool to violate that boundary to finish a contact. So in that picture right there, you can see that it's going to leave a little bit of a scallop there. When you turn the setting on, it's going to allow that in the upper right-hand side there to violate the boundary to finish that contact. So you kind of have that bluish line there that shows where the contact point is, and the tool is going outside or past that red dotted line now. Inversely, at the top of the part here, it's going to do the opposite, right? It's going to roll the tool up and over a sharp, like if we had a vertical wall there, it's going to roll the tool up and over that spot when it doesn't really need to, because it's already finished that contact. So what I've done here is just turn this on, and I want to look at this just in relation to the other one. You can see the tool paths are a little bit different. Obviously, we have a different level there. If I hover over this first one, you can see this one's going down a little further. So it's almost like the whole distance of that surface has been shifted down to finish that contact. Now, one other thing I did that you may have saw if you have a real keen eye, but in the toolpath settings here, I also did this, where it says additional offset. I made this minus a certain value, and I'm going to show you what happens when I make that back to 0, which is what the default is in the toolpath. You'll see it's going to make it a little bit messy. We have kind of all these weird, links and whatnot here. We have some spots over here that it wants to machine. And if you've ever seen this kind of waterfall effect, sometimes this will go all the way down to the bottom of the part. That's kind of the second part of what I want to show you, but let's talk about why it does this. So from the top of from the tool orientation here, when we look down at the toolpath, what happens, and I'm going to switch to design real quick, and let's do what I'm going to do. I'm going to tessellate this real quick, and I'm just going to say, show me a preview, and I'm going to say, make this medium or even custom. And when we zoom in here, you can see this is kind of made up of triangles here and showing us a little bit of that part outline. But what happens as the tool gets to the end right here where my cursor is, on some spots, the toolpath is going to end, right here. And on some spots, the toolpath is going to go outside that boundary. And that's what's going to cause that tool to kind of fall down there. So whatever tolerance we have set here when we create this mesh, which is what happens when we make the toolpath. I guess I'm kind of getting ahead of myself, but we go back to manufacture here. When we have kind of these dirty areas here, the tool is trying to touch those little pieces that fall beyond that tolerance boundary. So what do we typically do here, Phil, to fix this?
Tolerance.
Do what? Oh, make the tolerance tighter?
No, geometry.
Geometry. And this additional offset, we would make this negative, whatever that tolerance value is. So just for reference, my tolerance value here is 4/10. If we go to geometry and make this negative 4/10.
You could also just do negative tolerance.
Oh, you could do that too, right? I just want to keep it simple. But yeah, you could also, if you're Dr. Phil, you would type in here negative tol, and that's the one.
Yeah, tolerance. Perfect.
Sure. Hit OK, and it's going to do the same thing, right? It's going to plug in whatever that value is. So if we increased our tolerance now or decreased it, we wouldn't have to match two values, which is what my simple monkey brain would do. But if you're Dr. Phil, you would just link them together, and then you'd be way ahead of the pack. So hopefully that makes sense. The next thing I wanted to show real quick was just, we talked about boundaries a little bit. This is obviously how we'd create this toolpath. We go to the top here. Let me turn off the eyeball. You can see this is the area that we picked for the tool to stay within, right? This is kind of how we drive the toolpath. And this is going to give us, the geometry area or the spot that we want to machine from the tool axis orientation. We're pretending to be the tool right now, and we're looking down at the part, right? Z positive is facing towards the camera. So how can we limit the toolpath in other ways, right? Maybe a common thing that'll happen too on this, let's say the part ended right here and we brought this all the way up. The tool would never go past this part because it's not going to go past the model bottom. So what I want to show here is I have this contour toolpath. So in addition to whatever we have selected here for the boundary, and in this case I have a tool outside boundary selected because I want to cut the outside. On the heights page here, I want to show, a pretty simple thing and a pretty easy way to kind of limit some of these toolpaths from going deeper in spots that we don't want or getting certain areas machined. We obviously have the clearance height. This is where the toolpath is going to start and end. We have the retract height. So if we have different areas or segments, the tool is going to lift up to this height and travel across to go to our next segment. The top and bottom height, though, this is where the toolpath is going to get created. So what you'll notice, if I take this top and I drag this up and I drag this bottom and I drag this up, so I'm a little bit above our DMC logo there. When I hit OK, the toolpath can only be created in that region between the top and bottom. So this is another way that you can really limit a 3D toolpath to only a certain height by using that heights page. Hopefully that makes sense for everybody. Phil, anything to add real quick?
Beautiful. I think you said more than I could ever come up with.
All right. I got one other thing for you, and then maybe we'll cut to Jonathan's first question. Normally, when we go in here to do an adaptive, everybody pretty familiar with what this looks like. Obviously, we have a certain time here. I'm not going to change this too much, but if we go in here and simulate this, this is just a regular 3D adaptive. So I just picked a tool and hit OK, whatever my stock settings were. This is going to go around and it's going to start cutting this, and it wants to slot all the way through. That's just typical for this type of geometry because we had that level and it can go all the way through. And then it's going to kind of step up here to machine this. Now, does this look super efficient? I mean, it's probably better than pocket clearing or just doing some sort of offset roughing. But I want to show one other thing. Now, caveat to this, you would have to be an insider. So if you go to your preferences, go to your user up here, go to preferences, and you go down to preview features, up at the top here, it gives you the kind of the website here to try these Fusion previews by joining this insider community. So if you don't see this right now, you can certainly get access to this. But the one we're looking for is multi-axis clearing. Right here, this multi-axis clearing strategy, we want to turn that on, and then you'll have access to this toolpath. Now, this is going to do an adaptive, but on our 3-axis machine here, this can be really beneficial. Now, this toolpath is simultaneous 5-axis by default, and you would have to have the extension to use this. But if you put this to 3-axis mode, it's going to run kind of that same adaptive. You can see here in a little bit quicker of a time, and it's going to keep the tool locked to the floor, right? So as we go up and down here, you can see we're going to traverse, and we're going to do an adaptive here in 3-axis on this shape here. So this is a pretty cool way to use this. Obviously, this toolpath could keep the tool normal to the floor. Obviously, we'd have a little bit of a limit here with a flat toolpath, but you get the idea of how powerful this could be for some of this roughing. And obviously, looking at the two of them, this one's, similar settings, about, I don't know, 30, 40 seconds faster. What do you think about this, Phil? Did we lose him?
You're catching me because I wasn't paying attention.
Oh, no.
Oh, no. Start from the top.
Jonathan, I mean, what do you think about this? This is pretty cool to have this capability, right?
Definitely. Yeah, I think it's another unique way of roughing material, keeping the tool engaged with lighter spots, deeper spots. And then what blew my mind was how you kind of clean that up after the fact, which is, by smoothing everything out in what I would assume is the next toolpath you may or may not show.
Right. Yeah. So what Jonathan's talking about, and we're not going to have, this one doesn't give us kind of that same geometry we're looking at before. We had kind of a big step in there. Maybe that'll be an example for next week. But one thing we were looking at with, let me activate this, and another tip here, I have two setups here. Whenever you make click this little dot to activate it, that's saying any new toolpath is going to go in this setup. So that's what that little dot is for. If I go here and make a parallel, let's grab this tool and let's try to leave, turn on stock to leave here. And this may not work, so I guess I'm going down a road here, but we'll turn on rust machining. Actually, let's just try to cut one. Rust machining is fine.
I think that's how you did it yesterday.
Yeah. And we will hit OK. So hopefully this is going to do a parallel, and what we want to try to get it to do is do a parallel in just the spots. So let's hit function 8, in just the spots where we have these really, really tall ridges. See that? So part of the thing that's a little weird that we found out testing this, and this isn't a common toolpath setting that you would use. Here on the passes page, where is it at? I turned on geometry, I turned on rust machining, but you also have this ability to do multiple depths. Now, if these were really high and we wanted to cut this multiple times, I'm going to turn on this setting just so you can kind of be with us, but we're going to get lost here for a second. I'm going to say I want to take multiple depths, and I'm going to cut them at like 50 thousandths, and I want to do, let's just say 2 passes, which will give us 3 passes total. If we hit OK, it takes whatever the bottom pass is, and then it's going to step it up by that amount. So you can see here we get that exact same cutting path that we would have on the bottom here, and it's going to raise that up. So if we did have some hard material here, or we had a really small tool and we wanted to kind of rough those little mountains down, this toolpath we're getting at all levels is going to be the finished level, but it will get us close to eliminating a lot of the spots that don't necessarily need to be cut there. So you can turn off leads and links here, a little power mill trick. You can see kind of that region that's being machined there, and we're knocking down these ridges that were left over from this toolpath here. So that's all I had specific. We can certainly open it up to questions.
Mm-hmm. Yeah, it knocks down those steps and smooths everything out for finish, which is, I think that's going to be a really quick way of finishing something.
Yeah, it's probably a lot nicer than, oh God, what is that? What is it? Come on. Oh, the fine step down on adaptive.
Yeah,
that's what I used to do back in the day, but man, that would definitely slow down the roughing ups, that's for sure.
Well, yeah. I will show one other bonus thing, because I thought about it while we were talking here. If I duplicate this, you could actually kind of do this today without this toolpath. What you would want to do is come in here into design, and I'd probably go to surface. I'd go to surface offset, click on that. We'll hit OK, and then I'm going to go to extend. I'll show you this body. So we have this kind of surface body here. And I'm going to offset this a little bit bigger than the radius of the tool. I'm using a 1/2 inch end mill. So I'm going to offset this like 0.265. And I'm going to hit OK. And so now we have kind of this extended shelf here. And what we could do in manufacturing to rough this today, if we didn't have this capability, we can go into 3D, go to parallel, and we'll go to geometry here. I'm going to go to model. I'm going to turn on, I'm going to tell it I want to use this body. And I don't need it to calculate both of these bodies, so I'm just going to turn on include Senate model. And we should be going to the silhouette here, and our X is facing to the right, so we're going to have passes going left to right. It may start on the wrong side, but let's see. That starts over here, starts on the right side, and you can see what this did. We simulate this, and we are going both ways. So ideally, if I was roughing this and it was a hard material, I would set this to one way, and we could choose whatever our kind of adaptive optimal load would be here, and then you'll get those passes. So if we simulate this, you'll see that this is going to now come onto here, and oh, I have a bunch. You would want to go obviously the size of the material, the size of the part plus the stock that you have there. So we'll just make this to the nearest 0, and then that will give us what we want. So you would have added whatever that amount was, but this is why I had to do that, because our first pass will be cutting about nothing. So that value we could subtract a little bit of what we want our first pass to be, but as we go across here, and we probably want to also extend it on the edges there to have it not plunge down into the piece. So pretty easy to do that. Now that we kind of have a rough template here, we can go back and turn this body on, go to surface, use my little extend tool, grab that edge, and grab that edge.
Can you also use a bullnose tool for that?
Yeah, you can use whatever. I mean, not whatever, but you could use a bullnose. You could use a flat tool on this also, but you'd want to leave some stock to leave there. So I would usually do this for like a roughing or like a semi-roughing over a part, especially with like a big chamfer or something like that. So now when we simulate this, hopefully we got something that's usable. Don't have any more crashes. Bill's going to be happy. He's my pretend shop manager in this scenario. Now you can go across this part and rough that shape out using technology you have in Fusion today. Obviously, it's not an adaptive. It's not going around. It's not keeping a constant radial load, but it does keep whatever step over value here that we kind of told it. So I know I went super long. We're 20 some minutes in, but
so this is also a great roughing strategy for like thin walled parts. If your final form is going to be thin walled, because then you're taking, your
especially
finished,
if you're cutting something on both sides. Yeah, you can leave it thick and then just start doing this all the way down, essentially.
Yeah. This is one of those great examples where we get almost spoiled with how Fusion is so like solid model based that we forget sometimes the old school way of creating geometry for cut paths, like we have to do in so many other softwares. But making geometry is very handy.
Thanks for watching this video, guys. If you like this video and want to see more, be sure to join me over at the Digital Manufacturing Collective. You can get the DMC app on your iOS or Android device now in the Apple or Google Play Store. I'll see you over there.